This is an extension of the lesson from today in Algebra 2 on graphing absolute value functions. The first thing I'd like to do is take a look at the changes in the graph that happen when we graph modifications to the absolute value function. So in your y equals screen, if you want to graph absolute value, you have to go to math, then you go over to num, and the first thing is absolute value, and then you type in your x key. Some of you might have a slightly different calculator, but this is how you do it on this version. If we graph this on a standard window, which is zoom 6, you'll see that it's this V shape. Just remember V for value, absolute value. All right, let's see what happens if we put a negative in front. So if I insert a negative in front of the graph, what is that going to do to the shape of the graph? Now you know if you put a negative on a linear equation, it makes the slope go down. Well, guess what it does for an absolute value graph? It flips it upside down and makes it so that the arms, instead of opening upward, open downward. Okay, let's take a look and see what some of the other modifications do. If we multiply by a number in front, not a negative but just a constant, what does that do? Now you know if you multiply by 2 on a linear equation, it makes the graph steeper, it changes the slope. Well, it does the same for an absolute value graph. It's kind of a little bit difficult to tell, but it doubles the slope. It makes the slope twice as steep. Okay? What if you were to multiply by a half? Now that would be less steep than 1. And so, let's see, we're going to do 1 and insert over 2. Alright, so there's 1/2, and it makes it less steep than the original absolute value graph. Basically, it makes the slope be a half instead of just 1. Okay, what happens if you add or subtract numbers onto this function? Well, if you were to add 2, we're adding 2 on the outside of the absolute value, so not included with the x, but on the outside. What does that do to the graph? It makes the V shape move up, shift up 2 spaces. Now it's kind of hard to tell, but that is what it's doing. It's shifting the graph up 2 spaces. So adding 2 on the outside of the absolute value shifts the graph up 2 spaces. What if I were to, instead of adding 2, what if I were to subtract 4? So we'll subtract 4 and see how that affects the graph. That makes the graph, it used to go through the origin, now it's shifted down 4 spaces. So apparently, if you take the number that is after the absolute value, that tells you how many spaces to go up or down. All right, let me delete those. All right, let's go back to the graph and see what happens when you add or subtract numbers inside with the x inside of the function. So I'm going to change this to have x plus 3 inside the parentheses with the x. What does that do? Now if outside it moves it up and down, what does it do if it's inside? It moves it left or right. However, what's interesting is right here, this is a plus 3, but on the graph, it moved it left 3, which is a negative direction. So let's see if that happens again. If you follow the same pattern, if I subtract 5, what's that going to do to the graph? So I go over here. If adding 3 moved it left, then maybe subtracting 5 will move it right. Let's check it out. Yes, it did. It moved it right 5 spaces. So apparently what happens is whatever the sign is that's inside with the x, it goes the opposite direction. Now these ones did the normal thing. This one moved up 2, this one moved down 4, but this one right here, it moved left 3, even though it was positive, and this one moved right 5, even though it was negative. Now when I say it moved, what I mean is that the graph, the little corner point called the vertex, moved, and the rest of the graph moved with it. Okay. The equation y equals absolute value of x can be called a parent function because the parent graph, all the other graphs are like it. Now if you think about filling in this table, if you plug each of these x values in for x and figure out the corresponding y value, the absolute value of -2 is positive 2, of -1 is positive 1, 0, 1, and 2. And if you look at where these graphs points would be on the graph, -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2, you can see the familiar V shape. Now, if you were to plug in 3, absolute value of 3 is 3, absolute value of 4 is 4, you can see how it would extend this direction as well. Over here, absolute value of negative 3 is positive 3. Absolute value of negative 4 is positive 4. So you can see that the graph also goes this direction as well. Okay, so the characteristics are that it's V-shaped. Just remember V for value. The other characteristic is that it has what's called a vertex. And in the parent graph, the vertex is at 0, 0. All right, that's the vertex. That's the special point of this graph. And when that special point moves around, the rest of the graph moves around as well. Okay, its slope, the slope of the sides, is one of them is positive 1 and one of them is negative 1, because this one goes up 1 over 1, up 1 over 1, up 1 over 1. This one goes up 1, left 1, or going this direction, down 1, right 1. So it's negative this direction, positive this direction. So the slope is positive or negative 1. Okay, now what happens if we make adjustments to the parent function? They cause changes in the parent table and transformations to the parent graph. Stretching or shrinking, making it taller or shorter, reflecting it, or sliding back and forth and left and right and up and down. Okay, so the A, this is the typical form that we're going to see for all the different types of functions that we learned this year. This one's for absolute value. The number that's multiplied out in front of the absolute value will stretch or shrink or reflect the graph. We saw that from the previous slide, that when there was a number multiplied out in front, it flipped it upside down, or it made it taller, or it made it shorter. H and K are the slides. H is the horizontal slide, and it's negative because it goes the opposite direction of what it says. K is the vertical slide, and it goes up or down, and it goes the same direction that it says. The point HK, if you pull the H and the K out of the equation, that always gives you the vertex of the graph, and that's the special point that will allow us to graph it. Now basically this vertical stretch for an absolute value graph, since its sides are linear, is basically the same thing as slope. With other graphs it's not going to be like that. Okay, let's graph these first two examples. We're going to find the coordinates of the vertex, describe the stretch and or flip, and then graph the absolute value function. The vertex of this graph right here, first of all, this is the H, this is the K, and just remember that the H value, it's the opposite. So the X coordinate will be negative 3 because you do the opposite, and then it will be positive 2. Whatever's inside with the X, you do the opposite, and if it's outside, you leave it the same. So the vertex, the corner point of this V, is at negative 3, 2. Now the stretch or the flip is if there was a number in front of, if there was a coefficient in front of the absolute value, but there's not. So this one's just 1. It's just going to have normal stretch. It's going to go upward, and the slope is going to be up 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. All right, it's going to be a normal shaped graph, except it's going to have, its vertex has been moved. Okay, let's go to the second one. This one right here, its vertex is at 0, 0, and that's because there's nothing added inside with the X, and there's nothing added outside. The only thing that we have is this negative 2 coefficient. That is going to affect the stretch flip. It's first going to flip it upside down because it's negative, so it's going to be flipped upside down, and then in addition to that, it's going to have a stretch of 2. In other words, it's going to be 2 times as tall, or in this case, the slope is going to be positive and negative 2 from the vertex. That will assist us in graphing it. So first we graph the vertex. All right, the vertex is at 0, 0. It's going to go open downward, but instead of having the normal slope of up 1 over 1, up 1 over 1, it's going to have a slope of positive and negative 2. So down 2 over 1, down 2 over 1. All right, and on the other side as well, it's symmetric. So you can see that we okay, this is harder than it looks. Anyway, so we have, there's the graph right there. You can see that it opens downward. Hopefully yours looks nicer than mine. And yeah, it's more narrow than the other one because it's been stretched. Okay, let's do another one. Now this one has two separate modifications. The vertex is the first thing that we find. There's nothing added or subtracted inside with the x. So that's going to have a 0. And then there's a +3 on the outside. You don't change the sign since it's on the outside. So the vertex of this graph is going to be at 0, 3, which is on the y-axis. Now the stretch and flip, it's going to be flipped upside down because of the negative, and it's going to have the slope of the sides is going to be 1/3, all right, positive or negative 1/3. This means that it's going to, remember, rise over run, it's going to be down 1 over 3 on each side, down 1 over 3 on each side, all right, and it's going to open downward because of the negative. So there's two things that happen right here. It's downward and its slope is changed, and the vertex was moved up. I guess that's three things. Okay, for this next one, it has 3 different transformations here. All right, the vertex, remember, it's the opposite sign of this one, so that's +1. And then the y-coordinate would be -4, because you'd keep it the same sign. The stretch, it's still going to open upward because it has a positive coefficient. But the stretch, the slope of those sides, is going to be a half, positive or negative half, which means it's going to go up 1 over 2, down 1 over 2 from the vertex. So 1, -4, there's the vertex point right there. You always graph the vertex first. You always graph that special point. And that will be the case as we work through the year on other types of graphs as well. Okay, we're going to open upward, up 1 over 2, up 1 over 2, you know, just like graphing a line. Up 1, left 2, and this is this is actually, I know it looks like it's going up, but it's actually a negative slope since you're going backward. Okay, so there's 2 more examples. Now we're going to do a little bit of analyzing the equations to see what's the difference. Okay, what are the differences between these two? Let's take a look at these two right here. The similarities are that they both are going to have a slope of 2. The sides here are going to have a slope of 2, and this linear equation has a slope of 2 because the coefficients are 2. But the difference is this one is a line and this one is a V. All right, this one's going to be a line, this one's going to be a V. That's the main difference. Okay, let's look at these two right here. For these ones, the difference is this one has a +1 and this one doesn't. They're both going to have an x-coordinate in the vertex of -3. This one's going to be -3, 0. Sorry, that's a 0. And this one's going to be -3, 1. So they both have an x-coordinate of the vertex of -3, but the y-coordinate is different. This one is going to be shifted up 1 more space than this one. Okay, what's the difference between these two? The only difference between the equations is that there's a 2 right here. How does that change the graph? Does it change the vertex? No. The vertex of this equation is 0, 3, and the vertex of this equation is 0, 3 as well. So they have the same vertex, only this graph is twice as tall. So if this one looked something like this, then this one is going to be twice as tall. They're going to have the same vertex, but it's going to be taller. It's going to have a slope of up 2 over 1, whereas this one's only up 1 over 1. What's the difference between these last two? Do they have a different vertex? No. This one has the vertex of -1, -2. Remember, whatever's inside with the x, that's going to change sign. So -1, -2. They both have the same vertex. The difference is this one has a negative in front, so that's going to flip it upside down. So while this one is opening upward, this one is opening downward. Other than that, they're identical, and they have the same vertex.